Hi Akshay, very good morning. So, uh, I think we are waiting for you, but I think you are busy in some work. So let me just record this session regarding on NumPy, so that I will tell you Mr. Sami to share your recording for the same without wasting any time. Fine, please go through the recording. If you have any queries, we can discuss. Thank you. So basically, like what is NumPy? See, NumPy is the name itself is suggesting it is a numerical Python. Okay. So basically, this is a very powerful Python library which is used to do some data manipulation operations for your numerical data, complex numerical data in the form of matrices and okay. So in the form of matrices and arrays. Okay. So this is all about your NumPy. So as we discussed, so NumPy stands for numerical Python. So a library for Python programming language. So it is used to support large multidimensional arrays and matrices. Okay. So along with large collection of high level mathematical functions to operate on these arrays. Fine. So this is the official website of your NumPy and the release is 1.26. Even you can just check your official website. Okay. So go for your NumPy.org. So this is your official website. So this is a release is 2.0. So basically now it is 2.1 released. Okay. So this is how, and you can have documentation, you can learn n number of things, you can practice, all these things. Get started with your beginners, what is NumPy, n number of things, how to install your NumPy, all these things are there in the NumPy. So it's the best resource what I suggest for you to go through your NumPys. Okay. So so let us start your NumPys. See by importing your NumPys libraries to your Python. So basically, so how we import your pandas. So to import any libraries, first we need to import any library predefined functions. So first we need to import that library, right? So how we imported that pandas library. Similarly, if we also we import your NumPy library using a keyword called import NumPy as NP, where NP is an alias to your NumPy. Okay. So once we import, okay, your NumPy library, we use certain predefined functions. For example, array is a predefined function. Okay. Array is a predefined function. Okay. So inside your library called NumPy, which is used to create NumPy arrays. NumPy arrays. These are special types of arrays where, basically used to what you call deal with your data manipulation operations, are used to represent a data in your real-time information or structured, basically unstructured or structured data. So this is a process, this is a syntax to create your NumPy arrays. Okay. So basically I will pass this array. Okay. So inside your with help of your predefined functions. Okay. So using a keyword called NumPy NP. So np.array. So this is one thing, and stored in ARR, stored in ARR. ARR is basically it's a variable, right? So now once I store this array, I am printing this array. Okay. So what do you call uh, on the console of your Python. Fine. So let me do that basically. So just let me use your Jupyter Anaconda. So uh, in order to create your NumPy arrays. So already I do have a snippet of codes which I have created your friends. So let me just execute. So this is the program where I create your one-dimensional array. So basically we can create multi-dimensional arrays using your NumPys. So it can be one-dimensional, two-dimensional, three-dimensional, or n-dimensional array based on the requirement. Okay. So here the first step is I'm importing your NumPy as an NP. So then I'm creating your one-dimensional array. Okay, just by passing this constant, okay, to this array method. So and I'm displacing this one-dimensional array basically. So not to worry about this :4. I will explain you what is it. It's nothing but your array indexing. Okay. So let me just copy this program completely. So let me open a new notebook for you. Let me rename. Just copy this. Rename. So basically, this is Akshay file NumPy. So this is a file for you where you can just use it to practice your NumPy sessions. So basically, let me explain about this colon soon after in few seconds. So let me print array 1D. So let me execute it. Now see here we are able to print this one by what you call the array. We are able to create this array one dimension. We call one dimensional array. But how can you what you call identify what is the type of the dimensional array? So basically I can print array. I can use one keyword called end what you call the end dim. Okay, so let me just now see here end dim is a keyword which is used to print the what you call name of the what you call the dimension of the array. What kind of, because we don't know what is the dimension of the array. Let us use a keyword called endim. What is the type of this array actually? One dimension or two dimensions? What is one dimensional array? Now, what is this? Colon for what is this actually? It's called array indexing. See, for example, if you want what you call print the first value of, see, every element of your array. Okay, this is an array. Okay, every element of your array having its own index. So this is an array. So 1, 2, 3, 4, 5 is a NumPy array called ARR what you created. Every element of an array is having its own index. Okay, so index of this first element is 0, index of this first element is 1, index of this first element is 2, like this. This is called as element index. This is called as element index. Right? So now, so basically, I can access the elements of this array. So with the help of your element index. So just simply mentioning the index number in the square brackets. So mention 1. Okay, here. So just execute this. Okay, okay, sorry. So execute this. Okay, let me execute only this cell. Now, so the index is what 2 is the element that is stored in your index number 1. Similarly, okay, if I do index number 2, so basically, if I execute, okay, so is the element. Okay, so with the help of your array, it is nothing but your concept of array indexing. With the help of your array indexing, I can access the element index. I can access the element index. Fine. So similarly, I can create n-dimensional array. So now we created your one-dimensional array, and we created and we also accessed we also accessed the dimensions of the array with the help of array indexes. Now, what is this colon symbol? See, for example, if you want to access what you called uh, the elements in between the range. For example, I need an element between the range of 0 index to, that is colon, to third index, okay, or second index. So let me just see what happens. Okay, so let me execute this. Okay, so yeah, so now I'll get 1, 2. So 1 is the 0 index. Okay, obviously. So the second index is 0, 1, 2, the third index. That is, so when I say 1, 2, it will just extract the first index. Okay, then 2 means, okay, so one index before the element of the actually the element of the second index is 3. So it will extract one element before the second index. That is, it extract 1 and 2. It will extract the 1 and 2. So this is nothing but your slicing of your index, sorry, slicing of your array, NumPy array concept. Okay, this is called slicing concept. If you want to slice the NumPy array, yes, I can use it actually. Fine. So, so basically, I can slice these arrays like this. Fine. Okay. So then coming to your what do you call version? How can I find the version? See, this is a syntax to find your version of your NumPy arrays. np dot underscore version underscore. So just let me see what is the present version we are using. Okay, I think we have installed a new version, but let me check with this. Okay, so it is a new version 2.1.1. So which is the latest version what we are using as per your what you call NumPy website. Even it has released one more new version 2.1.1. Okay, so basically this is a 2.1 stable version what we're using. Okay, so this is how we use the latest version of your NumPy arrays. Okay, then let me create your two-dimensional array. So this is a code to create your two-dimensional array. Okay, so let me create your two-dimensional array. Fine. So let me execute it. So basically, I'm importing your numpys, then I'm defining your arrays, then I'm printing your two-dimensional array, right? And I'm checking your what you call the dimension of this array, right? So basically, these are called as tuples. So this is one tuple, okay? So in your arrays, we have a concept of tuples. So we have in one dimensional array, you have only one tuple, but in n dimensional array, we have different tuples. So this is one tuple, this is second tuple, this is your third tuple. So for every tuple, there is a tuple index. So this is a 0 is your tuple index, first tuple index. 1 is your first tuple index. 2 is your what you call third tuple index. In first index, okay. So basically, like every tuple will be having its own index again. So 0 is your again what you call the element of your first tuple index. So 1 is your element of your second tuple index. 2 is your element of your third tuple index. Okay, fine. So similarly, again 0 is your element of your first tuple index. 1 is your element of your second tuple index. 2 is your element of your, like this, every tuple is having its own indexes and element indexes also. So let me just execute this program. Let us see how it happens. So this is how a two-dimensional array is created. Now I want to access the elements of this basically two-dimensional array with the help of array indexing. Okay, let me access now. If I say, so in brackets, flower brackets, okay, just I will say 0 comma 0. So obviously the first the first index represents the tuple index. Inside that first zeroth tuple, okay, inside this zeroth tuple, okay. So basically 0 is the what you call the index of the zeroth tuple element. So this is the index of your first tuple. So 0. Now again 0 is the element of your basically zeroth element first. So obviously I'll be expecting the element to be printed it as 1. Okay, so this is a 1. That's it. So this is how I can use your indexes in your what you call to extract your values of your tuples, right? So now coming to you know so basically like uh, just we can also create your three-dimensional arrays. Okay, so this is your three-dimensional array. Okay, coding, just need to copy. So this is a three-dimensional array. What I can delete. So obviously I'm increasing my tuples in your three-dimensional array, fine. So basically, so just execute. Now see here, so just I can check the dimension of your array. So let me check the dimension of your array dot ending. Okay, so just check this. Now see here the three-dimensional array. The same thing, like how you can use your array indexes also to access the content in your three-dimensional array. Fine. So this is how we can define n dimension, different dimensions array. Now, how can we find the data type? See, we have many data types in your Python and array. See, for example, okay, so coming to your data types. So these are the data types, okay, that are supported by your Python, like string data types, where if you want to represent the set of characters, we can represent in the double quotes. Integer data types, whole numbers, the float as decimal numbers, Boolean, which is represented as true or false, complex as a complex numbers. These are the generic data types that is supported by your Python in general. But however, in your NumPy, mostly the same data types will be supported, but along with more data types. But your data types will be referred with a single letter like I, B, U. I means integer, B is Boolean. Then your small u means unsigned integer, F means float, C means complex. So capital M, small m means time delta, capital A means date time, O means object, S means string. Capital U is Unicode string. So V is void or check. So like this, these are different data types in your NumPy. So let me check. How can we check your data type? What of the array? What you created in NumPy? So how we check your dimension? For example, if you want to check your dimension of an array, we use ndim keyword. Okay. Similarly, to check I want to check. For example, I created this array. Okay, so I want to check the data type of this array. So how can I check? Okay, I can use something called as d type keyword to check the data type of an array instead of ending. What is that? D type. Fine. So just execute it. So integer. So basically it is int 64. Basically the 64 represents the range of the values it supports. Suppose n32 it is lesser range of integers it is supported. If it is n64 it is more range of integer is supported. Fine. So this is how we can find data type. So let us just create some arrays. So this is an integers array what they created. Let me create one string array, and let me check other data type what we like string data type arrays. Fine. So so this is a program where they are creating a one-dimensional, two-dimensional, three-dimensional string type array, and they are checking. So this is a one-dimensional string types, two-dimensional string type, three-dimensional string type. So let me check. Different data types. Okay. So dot d type. Okay, so d type is u6. What is u6? So it's nothing but your unified string. Just put your, so this is a this is u means unified string actually. So 6 is the range of the element or data that you can store. So up to 6 characters basically, string with the 6 characters. So this is how we can find the data type of your array. Now, not only find the data type, you can convert from one type to other type forcefully. For example, you are defining a NumPy array. You want this is an integer array, right? You want to convert into string array. So just pass this d type as string to use with your array method. Okay, and obviously, even though you are creating a NumPy array, it will display it as a internally it gets converted as a string array. Okay, so let me just, that is by passing the data type as a parameter to your array method, I can just convert one data type to other data type. So basically, so this is your d type. Okay, is equal to string. Then basically, so what I'm passing this d type, to your NumPy array, to your array. Fine. I'm passing this d type to your array. Fine. So basically, this is a array is a method which is used to create your NumPy array. It's a single dimension array, and by default it is a integer, right? So now I don't want to save this as integer, but I want to save it as string. So what I'm doing, I'm passing the string as a data type to this array, so that now if you check if you check and execute, so basically it is it is a string array. See here, string array. So the same thing we executed in the first program. Okay, so this is the first program, right? The same thing we executed. So if you see here, the data type. Okay, let me just okay, so 1D. Okay, so basically suppose, yeah, if you see here the data type. Okay, so just let me check d type. See that you are using the variable array 1D as a variable to store your 1D array. Here also array 1D, because now latestly you executed this. Obviously, again it will show the data type as a string only. Fine, that is a problem. Okay. So now here what we do, instead of that, SD underscore S will see, because it's a string data type. So okay, so that it won't replace. Fine. So just let me execute this. Okay, now go here, go to your first program and execute this. Okay, so now here it's still s1, the string s1. Okay, so that's what, see, basically whenever you execute the what the program in your notepad, so basically whichever the type is there, it gets executed latestly. There is a thing, basically these are all variables what it is created. Once you close your session, it gets what do you call it, so whatever it has been created, just this is a recent program what I executed. That is the reason why again it is showing an end type. So, but this is how we can convert from one data type to another data type. Now we converted from integer data type to string data type, right? So now see, they're taking they're creating one dimensional array, and they are trying to convert into different dimensions, like different types. They're trying to convert into float. They are trying to convert into what you called uh, what you call integer. They're trying to convert into string, all these things basically. Fine. So this is how basically, and we can just create one array and convert into different types of array. So here in this program, we created one dimensional array, and we are finding the type as one dimensional. Okay, then we converting into float. See, how can we convert into float? Basically, we have a method called as type. Okay, as type is a method which is used to convert from one data type to another data type. So to which data type you want to convert, just pass that data type to this as type. Now you want to convert to the float, pass that float to as type. You want to convert to basically uh, to your integer. Okay, pass it to as type. Fine. So you want to convert that to the string. Okay, So pass that to AS types. That's it. Very simple, right? So whichever the data type you want to convert, please pass that to AS type. Okay, fine. So just you can execute this. Fine. Now see here. So basically, we created your integer array. Now we converted the same into float. Even the data has been converted. Decimal has been added. Now this is the original float. What it's converted. Okay, fine. So now even it has converted to us what you called again we reconverted to integer. Again we converted to string. Okay, so string. So this is how these are nothing but your data type conversions. So one thing is I can pass your d type directly to the array method, or I can use AS type function for your data type conversions. Right. This is nothing but your data types and its conversions in your NumPy arrays. Right. So then coming to see how can we convert basically one data type to Boolean. See when I can convert to Boolean arrays, right? So for example, let me execute this program. Okay, so I have a program where I'm creating one integer data type. Now I'm converting that into Boolean here in the finally. So how this appears Boolean array? So which format? Like see just see here when you convert, basically it is appears in true like this true or false format. So basically, if the element is there in the, basically, how many elements are there, in your Boolean array, basically, what you called, okay, 1 minute. So basically, if you see, it is trying to convert, so all elements are present actually. So 1, 2, 3, 4, 5. That is why all are true. Suppose if it is 0, then, for example, if first element is 0, it comes to false. So this is nothing but your Boolean, what you call it, data type conversions. Just it will be converted into true or false. That's it. Apart from that, nothing. Okay. So yeah. So yeah, here we are defining your NumPy arrays. Okay, we are trying to convert. It's already into original float array. Okay. Fine. Okay, just take any kind of array. That is not a problem. What I'll do instead of making it as complex, let me take this array. Okay, so I'll print this array. Okay, copy this. So let us understand Boolean in a very easy manner and use this, code to convert this one-dimensional array to Boolean dimensional array. So ARR. So basically, let me use this. Okay. Now check. Now try to execute. Yeah. Now see here. Basically, it's a one-dimensional array 1, 2, 3, 4. Now what I'm doing, so all elements are present here 1, 2, 3, 4. That is the reason why you are getting 2, 2, 2, 2, 2. Now let me just in the fourth element, let me just use as 0. Okay, make it as 0 and explain this. Now see here, it is coming as false. So whenever it is encoding an element, it is true. Otherwise, it is false. Fine. Okay. Fine. This is nothing but your Boolean array. Boolean array are very powerful arrays. Basically, these are used to create something called as filter arrays. Okay, in your NumPys. Fine. Okay. Of course, you can use your filter arrays. So, basically, this is how we can convert your Boolean arrays. Fine. Then even you can reshape your arrays. Okay. So basically, what you called, for example, this is a one-dimensional array with 12 elements. You can reshape your one-dimensional array like 4x3 matrix. Basically, you have 12 elements, right? You can just whenever you are reshaping the dimension of an array, see that whatever the dimension you want now 4x3 dimension, right? Okay, so this total elements must be able to divide with this. So for 12 by 4, it is 3. It is 12 by 12 elements we have 4, it is 3. Okay, fine. Then 12 by 3, it is 4. It is 5. Okay, so like this, you should be see that it should be like compactable. Otherwise, you throw an error. Basically, you can't reshape the array whichever to dimension you want. Okay, it should be satisfy the condition basically. So now just this is a program where you can reshape the array. So just put it. Okay. So this is a basically dimension array, one dimension array with 12 elements. Now, what you call trying to reshape by using the reshape method. Okay, so I'm creating an int array and I'm trying to reshape. Now, basically, you want to first of all, this is the one dimension array 1 by 1. Now it is to 4 by 3. Okay, so just let me execute. Okay, now see here, it is a one dimension array Now it is a 4 by 3 dimension array. Fine. So basically it has 4 columns. Okay, so then it is a 3 rows. So 4 by 3 like that. Okay, so this is very important. Suppose if you try to what you call it view only 11 elements, so it will throw an error basically. You can't convert it to 4 by 3 because obviously 11 by 4 it is not dividing, 11 by 3 it is not getting. Now see here you are getting an error. Okay, so that's why you can't convert, you can reshape whichever dimension you need. It should satisfy the conditions to a reshape whatever you are reshaping. This is about you are reshaping the dimensions from one dimension to other dimensions. Fine. So then concatenating an array. See, we have two arrays. So array 1 and array 2. Okay. So how can we concatenate? Concatenation, see, basically this is array 1. Okay. So ARR is equal to 1, 2, 3. Array 1. Array 2 is equal to 4, 5, 6. So when we say concatenate, we use concatenated method to pass array 1 and array 2. Then obviously you will get a concatenated array like 1, 2, 3, 4, 5, 6. This is nothing but merging of two arrays. That's it. And you have vertical concatenation, and this is called as vertical concatenation. Okay, and horizontal concatenation also. So vertical concatenation means basically it will concatenate vertically like this. Now this is a horizontal concatenation. Just it will vertical horizontal it will merge. Vertical concatenation means it will merge like this. 1, 2, 3. Okay, 4, 5, 6 basically. Fine. So let's just me execute the code and get into the things. So let me just go by one. Okay. So regarding your concatenation, like this, we operate to perform data manipulation operations only on your arrays, NumPy arrays. Fine. Okay. So different matrices and vectors. So now we creating one array called array 1. We are creating array 1, array 2. Now we are using concatenation operator passing this array 1, array 2 to concatenate both. That's it. Fine. So now see here it has concatenated 1, 2, 3, 4, 5, 6. This is nothing but your horizontal concatenation to be frank. So let me just what you called use some vertical concatenation here in this. Okay. So okay. So let me create these two arrays first. Okay. Then let me use your vertical concatenation concept. Both let me use your vertical and horizontal so that you get a clear understanding what is vertical concatenation and horizontal concatenation. Okay. So so now here is a vertical concatenation. I'm using the method called vstack for the vertical concatenation of these two arrays. Similarly, hstack for the concatenation of these two arrays. Okay. So let us see the result, how it basically works. Fine. Now see here, this is a vertical concatenation. So just vertically it is concatenating all. Okay. So it is vertically it is concatenating. Fine. This is 1, 2, 3. Okay. Then second tuple 4, 5, 6. Okay, then 7, 8, 9. Okay, so 10, 11, 12. So it's a vertical concatenation. So horizontal concatenation means 1, 2, 3. Okay, basically, okay, these two tuples will be horizontally concatenated. Okay, 7, 8, 9. These two tuples will be horizontally concatenated. 4, 5, 6, 10, 11, 12. So horizontally, it is a horizontal concatenation. So like this, I can concatenate based on my requirement and the project. Fine. This is about your concatenating the arrays. Fine. Now, basically, how can we show the version even see, pip is a command. Pip is another Python package installer module where I can easily install your different types of modules like your pandas, numpy, spicebar, quarter maybe, right? So basically pip show numpy. This is also one of the method or command or keyword in order to verify your version. So basically this is how we can pip show method numpy. It is used to show the basically this is the version what we are using. This is a package and all. Okay, it's all about your numpy. You can upgrade, just if you want to upgrade now to the latest version. I don't know what is the latest version. Maybe, of course, I'm using 2.111. Suppose if you are upgrade automatically, just you need to say hyphen upgrade. Automatically, it gets upgrade to your latest version. Fine. Okay. Fine. So just click on upgrade, hyphen upgrade. So it gets upgraded to your latest version. If there is any upgradations in the version, it gets upgraded. Now again, we can check the latest version again. Okay, so it's already satisfied. The requirement is already satisfied. No need to worry. So again, let me check, is there any upgradations by executing pip show numpy. Fine. Yeah, the same version is there. Still new version is not been released. Okay, so 2.1.1 only. Fine. Just it's taking some time. Okay. Okay, so 2.1.2, very sorry, it has upgraded 2.1.2. Previously we are using 2.1.1, now we are using 2.1.2. So like this, oftenly every week, just you need to execute this pip show numpy upgrade hyphen upgrade, then basically you need to execute. Fine. So this is how you need to get into it. Fine. So now similarly for pandas also, you can upgrade to pandas, matplotlib. Okay, all these libraries you can upgrade to the latest version. Fine. Okay. So this is about your NumPy. See, basically what one thing you should understand here, NumPy is a numerical Python library in your Python which is used for your data manipulation operations on your complex arrays and matrices. That's it, right? So basically, in your real time, we use NumPy, which is a part of your pandas. Okay, so for your data manipulation or data transformation operations, especially on your numerical data, right? When you're dealing with your numerical data and your data science projects, okay, we use your numpys. So basically we use your pandas, numpys, matplotlib, okay, so and seaborn as a libraries for your to perform EDA, that is your exploratory data analysis, which is one of the critical step in your data science. So pandas and numpys, okay, so these libraries are especially used for your data manipulation or data transformation operations. And matplotlib and seaborn, so especially used for your data visualization operations. So we have completed your pandas and numpys in the, okay, so till now. In tomorrow's class, we'll start your matplotlib, which is one of the very powerful data visualization, like visualization. So whatever the visualizations you did in your Power BI, like your bar charts, all these things we can do with the help of your matplotlib also. And seaborn is a very powerful library which is built on the top of your MATLAB for your to perform your complex analytical visualization operations. Fine. So what we are doing now, all these things is nothing but your EDA. So basically, we write some code in your pandas and numpys to extract your data from the CSV, which is highly unstructured file. Then we are using some data transformations in your pandas and numpys. Okay. Then we are using your matplotlib or Cban to visualize your data. So this is nothing but exploratory data analysis. We are exploring the data and we are analyzing the data. This is one of the powerful steps as a data scientist, what you'll be implementing in your data science as a data analyst. Fine. Fine, guys. Fine, Akshay. So thank you so much. Please go through this recording, and if you have any queries, we can discuss in the next class. Thank you so much. Okay.